Hey everyone, welcome to May. It's almost the end of the year. You guys are going to be graduating soon, so we have one last big challenge for you, is finding out which one of these shapes is going to hold the most volume. We have three different shapes here. We have a cylinder, we have cone, and we have a sphere. If you look, obviously they all have circular components to them, and we can use our formulas that we already know about circles to help us find the volume. But before we get into the math, I thought it'd be fun to actually test out the volume for all three of these and see which one holds the most. So part of the challenge is you're gonna have to make a decision out about the cylinder, the cone, or the sphere, which one holds the most volume. And then we'll do our experiment here, and then we'll learn how to do the math when we don't have shapes to actually find the volume for it. Good luck. So I have my observations from my experiment here. I have the cone, the cylinder, and the sphere. So right now I have it as the sphere is holding the most volume based on the water that I filled it up with. And the cylinder's in second place. And then the one that held the least was the cone. And what I did then is I measured all of the 3D shapes. I measured the height, and then I also measured the diameter and the radius for each of the circles, which are the circular bases, and I wrote them down on these Post-its. So what I'm gonna do next is I'm gonna find the volume of each of them using math, using the formula for volume, and you're gonna see my work, and I want you guys to follow along. So you'll need a piece of notebook paper and something to write with, and a calculator, because we will be using pi, which can be a pretty complicated number. So, see you soon. So here we're going to find the actual volumes of the shapes that we are working with in our experiment. And we are going to revisit a formula you learned in 7th grade for volume, which is E equals capital B times H. Now the capital B is important because it stands for the area of the base. And if you look at a cylinder, the base, there's two of them, are circles. So we have to remember what the area of a circle is. And the formula for that, if you don't remember, is pi times the radius squared. And the height is represented by the height of a 3D shape, which here is connecting the two circles, and it's 5 centimeters. So we'll use the the numbers that we have and we'll put them in the formula. We also are going to remember to use the pi button. So V equals pi times the radius squared, and our radius we have is 2.5 squared. And then the height of this cylinder, the one that we had in our experiment, is 5. So we're going to multiply all of that by 5. Go ahead and try it on your own, and then we'll compare our answers. Here I'm getting 98.1747 and so on. And then to round to the nearest tenth, which is what we've been doing a lot with our work in the Pythagorean theorem, it's 98.2, and that's centimeters cubed. Volume's always cubed because it's a three-dimensional shape. So remember this number because we're going to compare it to the other shapes and see if it matches up with how our experiment went. Next is the cone. So here's a picture of our cone. You can see it's similar to our cylinder. The base is a circle, and there's a height and there's a radius as well. So our formula is also going to be similar. You are going to notice there is a fraction involved because cones are 1/3 the size of cylinders with the same measurements. So we are working with 1/3 times pi r squared, which is just like what we saw in the cylinder, times the height. Sometimes working with fractions can be confusing, so you can just multiply the numerator, which would be 1, and then divide it by 3, which is that, accounting for that 1/3 piece. And that's the one I'm going to work with here. Let's put in the numbers that we have. We have 2.5 for the radius, and then we have 5 1/4 for the height. Use the pi button. 2.5 squared, and then the height of this shape is 5.25. And then we will end that by dividing by 3 since it is a cone. Again, try it on your own and then we'll compare our answers. I'm going to start by just multiplying that top number, and then I'll divide it by 3 at the end. I'm not going to round until the very end. And after I divide by 3, I'm getting 34.361 and so on. And again, we're going to round to the nearest tenth. I'm getting 34.4 centimeters cubed. Lastly, we'll go ahead and look at the sphere and we'll make sure that our results match up. So if we look at a sphere, it's obviously circular, and we're going to see that there is no edges. We just have circular sides. So we only need to measure the radius because there's no difference with the size around a sphere. So this formula is a little different. It does include a fraction. It's 4/3 times pi times the radius cubed. There's no height because the radius is the height all around the entire shape. And again, you can use the formula a bit differently so that the fraction doesn't confuse you. And you would multiply by 4 and then divide by 3, which you can see the 4/3 comes into place when you multiply by 4 and then divide by 3. So when I measured this sphere that we worked with, I got a radius of 3. So if I use the formula, I have 4 times pi, use the pi button, times 3 cubed, and then divide the entire thing by 3. Go ahead and calculate that in your calculator, and let's compare our answers. The point where I did divide by 3, I already had multiplied by 4 when I did my work. When I divide by 3, I'm getting 113.097 and so on. Rounding to the nearest tenth is 113.1 centimeters cubed. If we make a comparison from the math to what we had done in our experiment, this all makes sense. The sphere holds 113 cubic centimeters. Secondly, we have the cylinder that holds 98 2/10 cubic centimeters. And then the cone held the least, which is 34 4 cubic centimeters. When we put all of our formulas together, we can use those to find the volume, and we wouldn't have to pour water into a clear glass every single time. So when you have these formulas, you'll typically get a formula card, and you can use those to help you solve any of the problems. Nice work.